Hello students, welcome to my channel The Field of Chemistry. I am Vijay Lakshmi. Now we are going to discuss about the nucleophilic addition reaction. In this, two reactions we are going to check. The first one, addition of hydrogen cyanide. Second one, addition of sodium bisulfite. Okay, now addition of hydrogen cyanide, we are following two steps. The first step, it is nucleophilic attack, that is a very slow process. The second step, protonation, which is very fast, proton transfers. Okay, now the second reaction also the same as it is. We are following the two steps. That is also the same nucleophilic attack. First step, it is a nucleophilic attack. The second step, protonation, which is very fast in reaction. Okay, now before we are going to go for the nucleophilic attack, that component which is going to attack that reagent, no? So that component should be a basic medium. So hydrogen cyanide means here hydrogen cyanide treated with the basic medium, there you will get H plus and Cn minus. That Cn minus is ready to attack with the nucleophilic attack. So, we have to treat this hydrogen cyanide or cyanohydrin. This is also we can say cyanohydrin. Okay, so this cyanohydrin, first we have to treat with basic medium. So, you will get the ions of H plus and Cn minus. Cn minus is the example of nucleophile that already you have got the idea from last video. Okay, now this is ready to attack for the nucleophilic addition reaction. Okay, now this is the first reaction part. Second one, what is the second reaction? Sodium bisulfite. So sodium bisulfite comes from hydrogen sulphite, H2SO3. Hope you got that. So what is the structure of H2SO3? S double bond O, this side OH, this side OH. It is treated with sodium hydroxide. Here you are getting what it is? S double bond O, here OH, here ONA. So here in this part, S double bond O, OH, here O minus, Na plus. So this part, it is a nucleophile. This is called what it is? Nucleophile. This is going to attack the positive point, that means positive ion of carbon. Last video I have explained what is nucleophilic attack. That means minus charge is ready to attracted by the plus charge of carbon. That I have given the idea. You just refer to my last video. You will get the clear idea about the nucleophilic addition reaction. Okay. Now, aldehydes or ketones, any one compound we are going to take. So, I just take aldehyde, CH3, here I have written H, double bond O. So, is this aldehyde or ketone? Of course, this is aldehyde only, CHO. So, I have written in such a way. Why? Because it is a trigonal planar. Why I have written? Because here H plus Cn minus, the Cn minus ion I have told you, no, nucleophile ions which is going to attack to that compound. Okay, here actually this is a slow step reaction. So what happens, this double bond, no, here it goes and attacks over here. When it goes attack over here, here you are getting what it is? Minus. Then what happened? This part it is plus. Now here this minus ion is attracted by the plus charge of carbon. So this is the nucleophilic attack. So what we are going to receive, it is C. Here CN will come over there. Then here CH3. Here H, and this side what it is, O minus. This is the intermediate compound. Okay. The next step, it is protonation. So protonation, actually this step, it is very fast step, which is protonation, which is ready to join with that proton is ready to join with the compound, so that is called protonation. So here the structure will be C, here CN, and then this side CH3, here H, and this side OH. So here this is what it is. This is called aldehyde cyanohydrin. Actually, this is acetaldehyde which is reacting with cyanohydrin, that is called HCN. Okay, so this is the reactant which is going to react with aldehyde. First thing, intermediate product, that is alkoxide we are getting, that is nucleophilic attack. That is the first step. There we are getting what it is, alkoxide. The first thing, aldehyde goes and attacked by the CN ion, and you are getting a intermediate compound, that is called alkoxide. And second point, it is a protonation takes place, which is very fast reaction. Here O minus is there, no, in that place H plus ions go and sit over there. So automatically you are getting aldehyde cyanohydrin. So IUPAC name we can give for this. It's very easy. How many carbons are there? 1, 2, 3. And then the first thing, cyanide compound, no? So what is the name of the cyanide compound in IUPAC name? Nitrile. Nitrile. Okay. Next to 1, 3 carbons are there. So that means what it is? Propane. Single bond only? No. So this is called propane only, not propene, neither propine. Propane. Okay, next one. In that second carbon, what is attached over there? Hydroxyl group. So 2-hydroxy propane nitrile. So this is the IUPAC name of this compound. Hope you understand. So one thing I'll tell you here, aldehyde, it is trigonal planar. This is sp2 hybridization. When it goes for the nucleophilic addition reaction, it changes to tetrahedral. That means 4 compound which is attached over there. Here only 3 compounds only there, but here 4 compounds, that is tetrahedral structure. Then again protonation, a complete, this is actually an intermediate compound. Here you will get a clear idea about aldehyde cyanohydrin. Aldehyde also is there, hydrogen cyanide also will be available. So this is a nucleophilic addition reaction of the first reaction, which is cyanohydrin, that is hydrogen cyanide is reacting with aldehyde, what you are receiving. Okay, I'll give some important hint about this point. The first one, in ketone, this reaction will be very slow. Why, you know? Because in that ketone, what it is there, already I have told the last video, steric hindrance will be available. That steric hindrance means what it is? Carbon is attached with the bulky group of alkyl or aryl compound. So that is why ketone will not take part in this reaction. The second point, this reaction occurs very slow purely with HCN. So HCN is added in the presence of base generalized with Cn minus ion to pops up. So then only you will get the stronger nucleophile. The stronger nucleophile which is ready to attack the positive charge of carbon. Okay, next one. The second reaction, which is called addition of sodium bisulfite. I have explained starting only. So sodium bisulfite, how do we get it? Which is treated with the basic medium. Sodium hydroxide is the basic medium. So hydrogen sulfide is treated with the basic medium. There you will get structure of sodium bisulfite Na plus and HSO2 minus ion. This actually helps to attach with the positive charge of carbon. That we are going to check. Okay, let us discuss about the addition of sodium bisulfite, that is nucleophilic addition reaction. In that, here also two steps we are going to follow. The first step, nucleophilic attack, that is very slow step. The second step, protonation, which is very fast. Proton, that means H plus ion, is going to join with the O minus ion. Okay, now the first one, we are going to take aldehyde only. So aldehyde, this is what it is, acetaldehyde. Okay, now acetaldehyde nucleophilic addition reaction takes place, means what happened? This is going to attack over there. So what happens when it going to join over there? So automatically this minus nucleophile, here it is a negative charge, it is a positive charge. So this negative charge of sulphite ion, which is going to attracted by the positive ion of carbon. So what happens? This is a trigonal planar structure. So what we are going to receive, which is sp3 hybridization of tetragonal planar. We are going to check tetrahedral planar. Okay, now carbon, which is over here. Here what it is? Here I have written in a easy way SO3H instead of that OSO2. So that means 3 oxygen is available. OSO2H. Na plus is waiting, I'll tell you later. So this is an intermediate compound, which is, this is a alkoxide. Okay, so this is a minus charge. And here next point, what it is? Protonation. Protonation, which is that H plus ion is going to join with the minus ion of oxygen. Okay, now here what it is, the step name? Protonation. Okay, now here see this protonation, this OH is going to attach over there. So this is the sulphite compound of aldehyde. Okay, now here what happened? Again we are treating with basic medium of Na plus. This Na plus is waiting over here. So what happened? This is exchanging. Protonation means after protonation it is exchanging the ion. Actually Na, this is Na. So just it is going to attach over there, and this point which is coming over here. Okay, now finally we are receiving the aldehyde of bisulfite ion. So here SO3Na, which is attached with the aldehyde ion. Okay, CH3CHO. Okay, now this name is called what it is? Aldehyde of bisulfite. Okay, easy to understand. Just I'll give you one review. Aldehyde, which is attacked by the reagent of sulphite ion, sodium sulphite ion, you are getting an intermediate compound. This is called alkoxide. Then the second step, it is called protonation. Protonation, here it is a transfer of proton. We are exchanging the ion. There finally you are receiving the aldehyde of bisulfite. Hope you got it. And I'll give some important points about the ketone. Due to steric hindrance, ketone reacts slower than aldehyde with bisulfate. Even here also, in this reaction also, ketone will not react much. Why? Because of steric hindrance. They may ask the question, why ketone cannot take part in nucleophilic addition reaction. Only the reason because of steric hindrance. You please remember this point. Second point, diethyl ketone, acetophenone and benzophenone do not react with sodium bisulfite. This actually sodium bisulfite will not react with such kind of diethyl ketone or acetophenone and benzophenone. These are all, why you know, these are all bulky group of alkyl or aryl compound, but acetone it will react slowly. Why? It is only CH3 compound only it's available, but diethyl ketone means carbon level will be higher than first one. So that is what. The next point, this product, which product? Aldehyde of bisulfite used for the purification of aldehyde. You know, this is, suppose if we are receiving this product, what product it is? What it is? Bisulfite of aldehyde. This product we are receiving, what it is? The product of nucleophilic addition reaction we are receiving. This product helps to purify the aldehydes and ketones, suppose if there is any impurities available. So further we are going to purify and then the reaction takes place for some other nucleophilic attack. The next reaction, it is addition of Grignard reagent. Grignard reagent, what it is? Or MgX. Okay, in this reaction, Grignard reagents react with aldehyde or ketone to give an addition product with an acid by hydrolysis. So, how many steps are there for this reaction? Means here also 2 steps reaction. The first step, it is addition product. So the addition product is nothing, what it is? Nucleophilic attack, which is going to attach over there with the carbon. Something is going to attach. So that is called first step, it is addition product. Second thing, it is hydrolysis. Hydrolysis is nothing, protonation. Protonation by acid. Okay, so these both are 2-step reaction. The first step, the same thing, nucleophilic attack only. Here I have given in a different way because addition product, we are going to add some compound over there with the carbon. So that is what I am telling, addition product for the first step. Second step, hydrolysis. Okay, now we are going to see the reaction. So what we are going to take, which is the main heading, it is a Grignard reagent. Grignard reagent here RMgX, alkyl or aryl magnesium halide. Okay, this is react with formaldehyde. Formaldehyde formula HC double bond OH. So this is a formaldehyde formula. Okay, now here what happened? Here this addition product is going to take. Now what happened? Suppose this is going to get over there, means naturally this alkyl group will go and sit over there. So this is a minus and this is plus. Okay, so this is actually here it is a plus. So this minus ion going to sit over here. So what is the product you are getting here? C, here H, here R, the same way H. Just I will write it here, OMgX. Okay, so this is the intermediate product. Then during hydrolysis, what happened? Here actually this ion will go and sit over there. This point it will go and sit over here. See here minus and H plus ions are going to sit over here. Here plus, it is a minus charge going to sit over there. So here what is that thing? R C H and here also H, here OH plus Mg, this side X and this side OH. MgCl2. So in only one halide it is there. Another halide, it is hydroxyl group sit over there. So what is the name of this actually? It is a product of Grignard reagent with formaldehyde. Okay, Grignard reagent with formaldehyde, we are getting what it is? CH2OH. Once I have told in my video, CH2OH, it is called primary alcohol. I have mentioned, you just go through my video so you'll come to know. So primary alcohol we are receiving through formaldehyde with the Grignard reagent. So this is the formaldehyde product. Now we are going to check with the ketone product with the reaction of Grignard reagent. See here, it is Grignard reagent is reacted with formaldehyde. We are getting the product, final product, it is primary alcohol. The second one, Grignard reagent, it's reacted with acetaldehyde. What we are going to check? It is a Grignard reagent. This is called Grignard reagent with acetaldehyde. There we are receiving what it is. So what happens? Naturally it goes upwards. Then this point it will come and attach over here. You are receiving the product of here carbon. This is the product we are going to receive. Here carbon attached with alkyl, that is methyl compound, and Grignard reagent in that an alkyl group is there. There you are going to check, and then finally you are getting an intermediate compound of Grignard reagent with acetaldehyde. Now second point, which is hydrolysis process, H plus OH minus ion. So H plus and OH minus ions, what happen here? This point which is going to attach, here bond breaks. So here H plus ion, here OH minus ion. Okay, now what you are going to receive? R C, here CH3, this is H and OH, plus Mg, here X, here OH. So here what do you feel? Here CHOH. CHOH is nothing. What it is, I have told last video. In my video I have told CHOH, it is a secondary alcohol. Secondary alcohol. Okay, now they may ask this question. Grignard reagent is combined with the compound and you are receiving a final product of secondary alcohol. So how do you write the equation? Or compound A combined with compound B, which is going to get the hydrolysis, you will receive the secondary alcohol. Or else Grignard reagent which is connected with the compound B, that means this is compound A and this is compound B. Okay, compound A, it is a Grignard reagent which is reacted with compound B. Through hydrolysis, we are receiving the secondary alcohol. What is the compound B? Like such kind of questions also nowadays available. Now, the next reaction, which is ketone, is reacted with Grignard reagent. Which is Grignard reagent or MGS. Grignard reagent. Okay, so this is what it is, CH3, CO, CH3, which is called acetone. the same way addition product it is taking place. So here what happens, the same way it goes there, and this point it is going to join over there. I will write it in such a way you will come to know. Here R, here CH3, this part also CH3, here OMgX. So this is the intermediate product which is going to get hydrolysis, H plus OH minus. So H plus ion will go and join over there, OH minus ions will go and join over there. So what you are going to receive, the product carbon, here CH3, or here CH3, here what it is, OH. So here Mg, X, here OH. So CH3, both the three sides CH3, and the last side it is COH. COH, it is what it is, tertiary alcohol. Tertiary alcohol, COH. You just remember, primary alcohol means CH2OH, that is a primary alcohol. Secondary alcohol means CHOH, it is a secondary alcohol. Tertiary alcohol means only carbon atom attached with hydroxyl ions, that is COH, it is a tertiary alcohol. Hope you got it. So what is the main idea I'm going to tell in this reaction? Grignard reagent means, Grignard reagent react with formaldehyde, you are getting a primary alcohol. Grignard reagent react with acetaldehyde, you are getting a secondary alcohol. And Grignard reagent is react with acetone, it is a tertiary alcohol. Here easy way I'll tell you. Grignard reagent combined with formaldehyde, you are getting a primary alcohol. Okay. Then Grignard reagent which is react with acetaldehyde, you are getting a secondary alcohol. Okay, third one, Grignard reagent is react with acetone, you are getting a tertiary alcohol. This is a exam tips for IIT JEE questions. Suppose if they ask, choose the correct answer in that. Grignard reagent is combined with formaldehyde. We are getting primary alcohol, secondary alcohol, tertiary alcohol, or all the above. Like that, such kind of questions you may expect. Just go through once. The next reaction, what we are going to see, it is addition of alcohol, which is very, very important. You just check it over there. Okay. Now, the first one, aldehydes or ketones. Whatever a reaction it may be, there will be some steps. If you follow the steps, it will be easy to understand, easy to remember. So addition of alcohol, there are two steps are there. Step 1, it is hemiacetal. The second step, step 1. Okay. Step 2, it is acetal. If you know the steps, it will be easy. In math also, if you know the formula, you will get the result half of that. The same way, reaction also. If you know the steps, what are the steps, how can you follow? If you find that steps, it is easily you can bring the products. In this reaction, I am going to take acetaldehyde. So this is what is the compound name? Acetaldehyde. Acetaldehyde, that is aldehyde compound, or OH. It is a CH3OH also you can take, which is very easiest one. CH3OH, methyl alcohol. Okay, now this is treated with dry HCl. Just you observe this, then finally I'll give the easy idea how to follow. Okay, now acetaldehyde is reacted with the alcohol in the presence of dry HCl. What you are going to receive, it is a first step. What it is? Hemiacetal. So before that, getting a hemiacetal, I'll tell you how you will follow the same nucleophilic attack only when this bond is going to attack over there. So this RO, okay, now this is going to attracted by the carbon ion, here minus and here it is a plus. So what is the product? It is carbon, here OH, here it is CH3, and this side OR and this side H. You know, see, carbon CH3 in this hydrogen ion will go and sit over there, because here H plus, so it will go and attach over there. So this RO, that these two things, it will come and attach over there. So here you will get what it is, hemiacetal. So what is the product name? It is called hemiacetal. Hemiacetal. Okay, now the second step, what it is, acetal you are getting. So acetal, naturally protonation takes place, H plus OH minus. See, nucleophilic addition reaction, commonly two steps you follow. The first step, it is nucleophilic attack. The second step, hydrolysis or protonation you just take. So these are the common step for all nucleophilic addition reaction. You remember that point? Okay, now after this hemiacetal, during hydrolysis, what happens? Water part, it will be removed. Then here also what it is, ROH will take over there for the reaction. Why? You know, actually two equivalent of alcohol, we are going to equivalent molecule of alcohol we are going to take. The first one molecule is react with this, and then we are getting a first one as hemiacetal, it is the intermediate compound. The second equivalent alcohol, it is second step it is going to take over. So here also that what it is, alcohol, there also the same thing, it's going to take place. What it is? Here acetal. So what happens here? Here carbon attached with OR, that is a ether compound of half of that. Hemi means, or hemi or semi means half. So half of the ether. Then second product you are receiving another half. So this part it is acetal. So methyl group is attached with the combined of ether compound. It is called acetal. I'll tell you very clearly now. See, hemiacetal is the first step. So hemiacetal, what happened? One part of, that means equivalent, two equivalent molecule of alcohol. One part of alcohol molecule only will go and sit over there, that is OR, that is an ether compound. OR means ether compound. Then the second step, again you are adding ROH. So what happens here? You are removing that OH part. Again you are adding what it is. Here OR, that means two ether group is combined with the alkyl compounds, that is called acetal. So easily you can identify aldehyde reacts with two molecules of alcohol. You are receiving the first compound, it is hemiacetal, which is only one ether group is attached over there. The second part, which is called acetal, both the side two ether groups will be available. So this is the aldehyde part which is reacting with the alcohol. Now we are going to check with ethyl alcohol. This may be a methyl alcohol. Now we are going to check with the ethyl alcohol. Okay, now this is what it is, acetaldehyde. Acetaldehyde. Then this is ethyl alcohol. Okay, now what happened? You know nucleophilic addition reaction, you know very well. Okay, so then this is minus and this is plus. So what happened here also? This is plus and this part completely minus. Okay, so this will go attacked over there and this part which is going to attracted by the nucleophile compound. Okay, now what you are going to receive? Carbon attached with here oxygen and hydrogen OH, and this side what it is? CH3, and this side OC2H5. Okay, then this is hydrogen. So this is what it is, intermediate compound, 1-ethoxyethane. So what is the name of this? 1-ethoxyethane. Okay, now again we are going to do with that what it is, hydrolysis H plus OH minus ion. In that what we are going to add again, C2H5OH, removal of water. So what we are going to receive, you know very well. Just you remove this OH ion, in that what it is? OC2H5 you just add. Okay. Carbon, this side OC2H5 and this side OC2H5 and this side CH3 and this side which is remaining hydrogen. So during hydrolysis water will be removed. In this here C2H5. So which is remaining this side actually? Here see this part OH is there, no? In this OH which is going removal of water, this part it is going away. So what happens here? H plus ion, this H plus ion, this OH minus ion combined, you are receiving the water, that means removal of water. In that place which is going to attracted over there, OC2H5, here you will get that idea. So this is, what is the name of this? 1,1-diethyl ethane. Hope you got it. See here, water molecules, how will you go? See here, H plus and OH minus ion. So H plus OH minus ion which is goes away as a water. Then OC2H5, it's a ether. That is what I have written. So what is the name of it? 1,1-diethyl ethane. So this is, what is the reaction? Acetaldehyde reacts with ethyl alcohol. First one what we have seen, acetaldehyde reacts with methyl alcohol, hemiacetal and acetal we received. In this second part, acetaldehyde reacts with ethyl alcohol, 1-ethoxyethane, that is oxyethane. This is ether compound. Okay, so 1-ethoxyethane and then 1,1-diethyl ethoxyethane. Okay, diethyl 1,1-diethoxyethane you will receive. This is the final product of ketone, acetaldehyde. The next reaction, it is ketone reacts with ethylene glycol. So what is the ethylene glycol ketone? How can you write it commonly? You just write it here. Carbon attached with CH3, C double bond O. Okay, for a reason I have written like that, CH3CO, CH3, it is a acetone. Reacts with ethylene glycol. So CH2, CH2 here, OH, this side also OH. So this is ethylene glycol. Okay, I will write it here, ethylene glycol. Ethylene glycol. Okay, this is acetone. Okay, now what happens? It's a removal of water again here, a removal of water. Very fast the reaction takes place with acetone. What happens here? What it is? H2. Easy way you can remove water. See, like this. So that is the purpose I have written like that. Easily you can just instead of H2O, you just write as it is, whatever it is remaining. Okay. Now here carbon attached with methyl group, down part also methyl group, and then this OCH2, this side also OCH2, just as it is, whatever it is remaining, you just write it. So what is the name of this actually? Ketol. What it is called? Ketol. Acetol, it is with acetaldehyde. Ketol, which is ketone form. Okay. 2,2-dimethyl 1,3-dioxone. Oxalane, we can say oxalane. Oxone, it is coming with ammonia derivatives. It is oxalane. Okay. Now come to this point. I'll tell you once again. This acetone reacts with glycol. This is also one kind of alcohol only. What it is, diol, they will say, no. So it is a glycol which is react with the acetone. Directly you will get the product. What it is called? The same way, you just remove the water molecule, there you will get the product. Just remove the water molecule, there you will get the product of 2,2-dimethyl, 2,2-dimethyl and 1,3-dioxolane. Actually, this is a functional group, carbon 1. So here 1, carbon 2. So 2,2-dimethyl, 1,3-dioxolane. This is the way we can name that. Oxyl group is there, no? That is what we have written like that. So, just a recap once again. In this nucleophilic addition reaction, first thing we have seen hydrogen cyanide, how it is going to get that attack by the nucleophile attack. Second one, protonation. The same way, same step follows for sodium bisulfite. That is also another reaction. And then third one, Grignard reagent we have seen. Fourth one, addition with alcohol. So alcohol, if it is reacted with formaldehyde, acetaldehyde, ketone, whatever it is. So what formation we got it, that you come to know. The last one, what we are going to see the upcoming video, it is addition of ammonia and its derivation. That is very, very interesting and easiest tips I will give you. Please watch. Thanks for watching. Please subscribe my channel. Thank you once again.